So scientists have finally broken through that bottleneck on the way to AGI. The mouth. While humanoid robots are getting more agile to avoid the Uncanny Valley effect, manufacturers deliberately steer clear of facial features, especially the mouth. Otherwise, they just open and close like a puppet, out of sync with their voice. What? Real Canadians aren't like that? South Park fooled me? How is that possible? In a new study from Science Robotics, scientists built a robot with a soft silicone face. The face has 10 movable parts. They also taught it to move its lips in sync with speech, just like a real person talking. No, not parents, YouTube. A Columbia University engineering team designed a mechanical structure with 10 independently controlled points under soft silicone skin. Using precise cables and linkages, it mimics the complex movements of the orbicularis oris muscle around our lips. It can open and purse its lips, smirk, or even display complex micro-expressions like, "I dare you to bite me." This hard skill helps it escape the uncanny valley, but what truly allows it to say, "Tell me what you want, tell me what you need," is its ability to convey a wide range of emotions through nuanced facial movements, making interactions feel natural and engaging. Is it soft soul, self-supervised learning? The training process has 2 stages. The first is motor babbling. When the robot first turns on, it has no idea what pulling motor number 3 will do. It must observe itself in a mirror like a baby babbling and exploring its own body. And perform facial acting training. It randomly twitches those 10 facial muscles, sometimes twisting its mouth, sometimes pouting. Then it uses a camera to watch its own face, recording how each motor command changes its appearance, just like Deku imitating All Might in the mirror. Crucially, this process requires no human data labeling. Through thousands of self-observations, it builds a unique visual motor muscle memory model. After mastering muscle control, the next stage is cross-modal translation. Scientists used a system to generate synthesized videos of the robot itself talking, simultaneously activating 2 AI models. First, a variational autoencoder compresses the robot's mouth shapes from these synthesized videos into a set of simplified machine-understandable codes, much like the data codes you'd find in a character creation system. Next, we have the FAT architecture. It operates similarly to ChatGPT, but instead of processing text to predict the next word, it focuses on facial movements. It reads the sound waveform, then predicts the next mouth shape, and converts that into action commands for those 10 motors. How powerful is this? When we're about to say Baba, our lips must close tightly and build up air before the sound even emerges, right? This intricate coordination is key. Traditional robots open their mouths only after hearing a ba sound, often half a beat late, making them look like a poorly dubbed movie. But because FAT has the transformer's attention mechanism, it doesn't just listen to the present, it also analyzes the preceding and following speech context. When FAT detects this audio feature, it sends commands to the motors in advance. Hey, motors 3 and 7, close tightly now, then burst open in 0.1 seconds. This precise prejudgment allows the robot mouth to exhibit the corticulation phenomenon unique to human speech, making the mouth shape and sound perfectly synchronized. To put it simply, it doesn't just memorize words. Instead, it directly translates auditory information, like sounds, into motor information, such as muscle contractions, achieving end-to-end learning. Currently, it achieves nearly perfect lip sync across 11 languages, even for complex phrases like chocomint or avatar. However, scientists admit that some sounds requiring closed-mouth bursts of air, plosive sounds like B and P, or the extreme pouting for W still pose challenges. Silicone isn't as flexible as human muscle, however, physical VTubers' mouth movements will soon be much more sophisticated. It will perfectly match the performer's words, perhaps even adding an ending fairy. I mean, if robots can master mouth control just by watching YouTube, imagine what they could learn if they watched, say, a professional speaker or even a singing lesson. The possibilities are fascinating.